it's Ashley from Smart Edition Academy. We are going to dive into interpreting graphics. So if you're not sure what that means, essentially what we're going to be doing is looking at different types of graphs as well as different areas of statistics that you'll need to know for your entrance exam. So if that sounds interesting to you, definitely stick around. I have a lot of examples for us to try together today. Statistics is usually one of the more fun and exciting topics because it can be really relevant to our life and really applicable to, what's happening in the world around us. So I hope that we can find some ways to tie that all together today. So the questions we're going to answer together: what kind of graphs do I need to be familiar with? So we'll talk about the three main types of graphs that you want to be familiar with in order to be successful on your exam. What other parts of statistics do I need to know? So we'll talk about some of those. And then, of course, what will the problems look like? So we'll do a bunch of examples together today. Before we get started, I'd love if you had something to write in, like a notebook, a piece of paper, whatever, something to write with, a pen, pencil, whatever you can find. That way you can participate with me as we do some of these example problems. And also having a 4-function calculator is going to make this so much easier as we dive into some of the statistical terms and processes. So the 4-function calculator, basically meaning you can do addition, subtraction, multiplication, and division. That's what you will have access to on your entrance exam. So having that available to you now will just allow you to practice a little more efficiently. Okay, so we're going to dive into this. So interpreting graphics. Let's see what that means. So the first question we wanted to answer was, what type of graphs do we need to be familiar with? So the first type of graph is a line graph. So you may have seen something like this before. This is just a sample line graph where essentially you would have the title up here at the top. Okay, so what is this graph about would be up there in the title. Then you would have labels on the side. Okay, so this is the vertical axis and then the horizontal axis. In this case, we just have quantity and time, but those labels can be a variety of different things when we're talking about a line graph. So line graphs are really great if we're talking about like frequency or, again, quantity, which is here on the vertical axis. And you may also see, we will definitely see an example of this later, some double line graphs. So say you had another color on here, you could have, another line graph, another line on here, which would make it a double line graph, which is great for comparing data, say from like two different sources or, two different time periods. Maybe we're talking about temperature and you want to compare the temperature in different seasons, for example. I don't know, lots of different ways we can use line graphs, okay? So just to go back to this is essentially what you can expect to see. So a few points about this line graph specifically. We have, again, our labels. We have quantity, we have time. Notice the time one isn't really labeled. Typically it would be, so let's say, for example, this would be 0. And then maybe this is like time in hours. So this might just be 1, 2, 3, 4, 5, 6. So typically you'll actually have these numbers labeled. I want to point out on the vertical axes, it goes from 0, and then the first line that you see jumps to 2. So then it goes 2, 4, 6, 8, 10. So notice how it's counting by 2 every time. You want to just be aware of that scale of your graph of the label on that vertical axis, because if you look at right here, for example, it's in between the 4 and the 6. So you have to be able to kind of figure out what is that value. So it'd be right in between 4 and 6 would be 5, obviously, right? So this one also lies in between like 2 and 4. So that would be a quantity of 3. So you just want to be aware of that as you are looking at your graphs. Okay, so this is what we started with, basically just a line graph, and we'll dive deeper into some examples. You can see, how we will use these types of graphs and what type of questions you will need to answer. Okay, bar graphs, another great type of graph to be familiar with. So again, we would have a label at the top. Okay, so this is essentially, what is this graph telling you? What is this about? And then we have, so that's the title, and then we have the labels here. In this case, this is quantity and category. So bar graphs are really great if we're talking about categorical data. So this word category or categorical data, also known as qualitative. Okay, so just a couple little key words there for you. That's essentially if we're talking about something that can't be expressed as a quantity or as a number value. So maybe we're talking about different colors or different types of pets or students' favorite subject in school. That is all different types of qualitative data versus a quantity or a frequency. Okay, another word for that might be frequency. This is what we would call quantitative data. So that's basically something I can count. Okay, so our bar graphs can be really great for categorical data. Doesn't have to be, but that is just, in this case, pointing that out. You'll notice that we see that quite a bit with our bar graphs. Again, these are something that you could potentially see as a double graph. So you could have a double bar graph here where, say, this label A, maybe we're talking about, I don't know, students' favorite lunches. You might have a section for boys and a section for girls. So you might have a double bar graph here. So it would compare the data. So double bar graph, we will again see an example of this later, but this is great just for comparing data. The visual is really, really helpful in order to see the difference in that comparison. Okay, so far we've got line graphs, we've got bar graphs, and then the third type of graph I want to talk about is a circle graph. So we have a circle graph, and notice how it's split into a bunch of different categories. So up at the top, again, we have our title. What is this graph about? And now for our circle graphs, all of our labels are just within here. So basically, what are the different categories or labels that you might have? And then rather than having just a set quantity or value, we use percents when we are talking about circle graphs and using this visual for data. So it's important to be able to create these types of graphs as well as just be able to analyze them and understand them. So a couple things about circle graphs that are important. You need to know that there are 360 degrees in a circle. Okay, so why is that important? Well, if you had to create a circle graph, okay, and let's say that we have a couple different things going on here. Let's just keep it simple to start. So let's say 50%, okay, of, I don't know, 50% of people's favorite meal is breakfast. Okay, so breakfast, lunch, or dinner. So 50% of people said their favorite meal is breakfast. Well, in order to figure out how to draw that line, in this case, 50% is pretty easy, right? You would just draw a line down the middle, okay? That is because 50% is half of the whole thing, and half of 360 is 180. So you would need to create a 180-degree angle, which if you remember from some of our geometry stuff, and if not, you might want to check out our Smart Addition lessons, half of that 360, 180 would create a straight line or a straight angle, leaving this. So let's say instead of something that's simple, what if we said, well, 1/3 of people think that lunch is their favorite. So 1/3 of 360 would give me 120. So I would need a 120-degree angle here. So I'm estimating a bit, but essentially from the center, you would have to create a 120-degree angle to show that 1/3, or we would round that to about 33%, Okay? And then you'd have the remainder left over, which in this case would be like 17%, I think, is what's left. I'm just kind of making this up as I go. So that sounds about right. Okay, so this allows you to find the angle measure of each section of the circle. Okay, so that's why it's important to know the 360 degrees and how to figure that out. Really, this will come up, on occasion. It won't come up as much as being able to analyze. So let's just talk about some things we need to know to analyze these circle graphs as well. We need to be able to take percentages, okay, and they're graphed. We need to be able to understand that, first of all, the percentages should always add to 100. So when you add everything together, or if you're trying to find a missing piece to a circle graph, the key is that it'll always add up to 100%, right? And then we'll see a few examples of what we have to do if, say, we need to find the actual value of one of these sections. So like say this is about like people's bills, and this is about their income. Their total income is split in between all these different categories, and 20% of their income is spent on their mortgage. Well, you'd have to figure out how to find 20% of the total. So we will go into that a little bit. So we'll do a little bit of a review of percentages in algebra. Okay, so that was a lot of talking, but I did want to just reiterate and take my time going over those three graphs because we're going to focus on those and look at some examples going forward. All right, so again, if you have your paper, pencil, calculator ready, we're going to do some examples. Okay, so here's an example of a line graph. Just zoom out a smidge so I can make sure you can see the whole thing. Okay, so before I even give you the question, let's just talk about what this graph tells us. So we have our title, commuting times. So this graph is telling us, is demonstrating the occurrences of different amounts of commuting times. So for example, maybe you live in the city and you have a different commute every day because of traffic. You could keep track of how long this commute takes you over the course of, a month or whatever, and track how the occurrences to see, what is the average amount of time it takes me to get to work? What is the longest it takes me to get to work? What's the fastest time I've ever gotten to work? And just, that's how this kind of graph can be helpful. So in this specific one, let's just keep a pretty basic question here to analyze this. So which commuting time happened the most? Okay, so which commuting time happened the most? So I'm looking for the one that happened the most amount of times or had the most occurrences. So I'm looking at the vertical axes here, trying to find which point on my graph is the highest. So I noticed that this looks like the maximum. That is what it is the highest. So what this tells me is that it took 20 minutes to get to work on 5 different occasions. Okay. So to answer the question that I asked, which commuting time happened the most, that would be 20. The commuting time that happened the most is 20. Okay. Now, which one happened the least? Well, I'm going to do the same kind of thing and look at my occurrences, look at the vertical axes and see which one is the lowest. And the lowest one is here. So a commute of 40 minutes only happened one time. Okay, that is the lowest occurrence. So the one that happened the least would be 40 minutes. Okay, so pretty basic example to start, but we just want to be able to read these graphs efficiently. Quick math interruption. If you're studying for the TEAS exam, check out the TEAS online course from Smart Edition Nursing at smarteditionacademy.com. The course has everything you need to study in one place to make studying easier, and it's guaranteed to help you pass. Now let's get back to reviewing math together. Okay, let's try something else. Okay, let's look at this bar graph. let's just try to analyze what it's telling us, and then I'll give you the question. So our title is Summer Vacation. The vertical axis label is distance, and then the bottom is family. So again, notice how when we're using a bar graph, a lot of the times it's categorical data. So here we are talking about different families. So these are just the names of different families, but we can still note frequency, or in this case, we're talking about distance. So we still have some sort of quantitative data here. So essentially what we are comparing is the distance that families traveled for their vacation. Okay, so who traveled the farthest? If we are looking at this graph, trying to figure out who traveled the farthest, okay, would be whichever one went the highest. So if I'm looking here for the highest bar graph, this looks like the highest. So the Clark family traveled the farthest. Okay, this graph looks like probably is just missing this top label of 500. So if we had to figure out how far they traveled, this would be right in between 400 and 500. This would be 450, and let's just assume this is distance in miles. Okay, I'm just giving you a little more information here for these made-up scenarios that I have. Okay, who stayed the closest to home? So go ahead and drop in the chat if you think you can tell based off of this graph which family stayed the closest to home. And then if you can also figure out what that distance was, we'll say it's in miles, go ahead and drop that in the chat as well. So it looks to me like if we're looking for the one who stayed the closest to home, who traveled the least amount of distance, it would be the lowest bar here, which is the Silva family. And if we just go over, right, that's where we can find how far they traveled. They traveled 200 miles. Cool. So again, we'll look at some more examples and different ways that we can use these, but lots of questions we could ask just from this fairly basic bar graph. You could find the average amount of time or distance that these families traveled. You'd have to find the average of all of these, which we'll talk about how to do that in a bit. You could find the range. What is the difference between the highest and lowest, which would be pretty easy for us now because we have the highest at 450, the lowest at 200. Range is just the difference between the two. We could give more information about the speeds at which they traveled and figure out how long it took them to get to each vacation. Lots of different things that they can ask from simple graphs like this. All right, now let's look at a circle graph example. So this circle graph shows us favorite subject. So our title here, favorite subject, is what this pie graph or the circle graph is about. And then I have all of my different percentages here. So just by looking at this, the visual is so helpful because it seems like, at least just even without the percentages, you could kind of tell which are the more popular subjects, which are the least popular subjects. And that gives you a place to start in an understanding of the information, which is the whole point of these graphs. Now, if I had a more specific question, let's just say which one is the favorite. So if I'm looking for the favorite subject, I'm looking for the largest portion and also the largest percent. So STEM, this is the favorite subject. This one has the highest percentage, followed pretty closely behind by English. Now, what is the least favorite? So we're looking for the one that has the smallest percent or the smallest section of the circle. And this one here, art, would be the least favorite. Now, what if I asked you to figure out, okay, let's say 10,000 students were surveyed, okay? If 10,000 students were surveyed, let's figure out how many chose each subject. Okay, so this is where we have to then pull in our knowledge of percentages of algebra to find the solutions. So if 10,000 students were surveyed, essentially what you have to do is you have to take your percent, write it as a decimal, Okay, so even though these have decimals in it, the percent sign means out of 100. To rewrite it as a decimal, you have to swoop the decimal to the left twice. So rewriting each of these as their decimal version, okay, looks something like this. This is also the same as dividing by 100. Okay, so that's the first step, is to turn these percentages into decimals. Then what you do is you just multiply the 10,000 students by each now decimal version of the percent. So I'll just do a couple examples. Let's say for STEM, 10,000 times 0.2941. This is exactly why you want to have a 4-function calculator handy and ready to go, because you can just plug that in your calculator. Okay, so I'll just write it out so we see what we're doing. 10,000 times 0.2941 gives me 2,941 students. So that's how many students surveyed said that was their favorite subject. Let's look at math. You take the 10,000, multiply it by the decimal version of your percent. Okay, and it would be 1,176 students. Okay, so I could do that for each subject. Okay, one thing to note about circle graphs is that oftentimes when we're using percentages that aren't like super nice and easy, there will be rounding errors. So I know I specifically said in the beginning it should add to 100%. If it's off by a percent or a fraction of a percent, that's pretty normal when we're talking about these types of graphics, because you want to round to make it like friendly and easy to work with. So that can throw off the summation of the percents by a little bit, but it should not be very far from 100, if at all. All right, good. So let's look at some other examples. So I said we would see some double graphs. So this is an example of a double line graph. So let's analyze what this is telling us. It says basketball scores, okay? And then the vertical axis is points, and then the game. So now I have a red line and a blue line. So here I have what we call a legend or a key that tells me what each color represents. So red is the points scored, blue is the points given up. So if I'm talking about basketball, right, talking about a basketball game, if I score more points than I give up, my team wins. If I give up more points than my team scores, we lose, right? So let's use that information to answer a few questions. So how many games did they win? So if we're looking at our points scored and points given up here, let me just change my color. Let's just use green for now so it's not confusing. Let's say, whoops. Okay. Again, the question is, how many games did they win? Well, the points scored needs to be higher than the points given up. So if I'm looking at game 1, points scored is more than points given up. So they won this game. 2, really close, but notice how points scored is below points given up. They did not win this game. 3, points scored and then points given up. So they won. 4, points given up is on top, points scored. Nice, they didn't win that one. So I'm just going one by one to see if they won or not. Okay, 6, again, another close game, but points scored is on top. And then the last few looks like they really got in their groove and they won a bunch. So how many games did they win? 1, 2, 3, 4, 5, 6, 7. So that means how many did they lose? They only lost 3. Okay, so I could figure that out based off of just kind of being able to analyze this graph and know what each line represents. Okay, what was the largest win by? Okay, of all of their wins, what was the largest amount of points that they won by? So we're looking for the game that has like the largest discrepancy between points scored and points given up, but it has to be a game that they won. So it looks like game number 10 would be it. So how many points did they score? Well, again, remember how I said how important it is to notice the scale of your axes? I'm going from 50 and then there's a box, and then 56, a box, 62. So I'm going up by 6 over the course of 2 boxes. So each box is really just 3. So I could go through and label this a little more if I wanted to. That could be helpful, just to make sure you know exactly what you're talking about. But it looks like they scored 77 points here. And how many points did their teammates score? Well, 53 to 56. It's like 2/3 of the way up. So this would be 54, 55. So 77 minus 55 would be a difference of 22 points. So their largest win was a difference of 22 points. What was their largest loss? So when they lost, which game had the largest discrepancy? So it looks like to me that would be game 5. Okay, that would be game 5. So their opposition, the other team here, 68, 69, looks like that would be about 70. And this is what they scored, 56, 57, 58. 70 minus 58 would be a loss by 12 points. Okay, so just an example of how you might see a double line graph and have to analyze it. So again, statistics and using these graphics is really great because these are really applicable. You may have played sports in the past or currently play sports. You may just be into watching sports. These are ways that we can visually represent data that makes it a little more understandable and allows us to pull out important information. All right, let's look at a circle graph. The circle graph shows the number of votes for each candidate. How many votes were cast for candidate D if there were 25,000 voters? So I'm just going to zoom in a little bit because it's kind of hard to see these numbers. Candidate D is what we're asking about. So that is down here, 28%. So votes for candidate is the title of this graph. So 28% of the votes were for candidate D. Well, 28% of the total, said 25,000, is what we have to figure out. Okay, all right, 25,000, yes. Okay, so again, in order to figure out questions like this, we need to turn our percent into a decimal. So we swoop the decimal to the left twice. We basically just have to multiply 0.28 times 25,000. So go ahead and plug that in your calculator. Feel free to drop it in the chat if you think you've got it. And what I am getting is that 7,000 people voted for candidate D. Okay, we could have asked the same question for any of these. You could figure out, how many people voted for any given candidate in this example. Okay, so here we have another line graph. The question is, what is the average amount of rainfall per day for the 12 days of data shown? I'm going to zoom in a little bit. We have rainfall amount on the vertical axis. I have the amount in inches, and then the 12 days are on the bottom. So the question is, what is the average? Okay, so I'm just going to scroll down here a little bit to show my work. To find the average, this is also known as the mean. Another way they could ask that question is to use the word mean. So the average is just adding up all of your data and dividing by the number of data points you have. So we have to go through and figure out the value of each of these 12 data points. Okay, so let's do that. We'll add them all together and divide by 12. So noting my scale here, I go from 0 to 0.4, and that's 2 jumps. So right in between that, this one would be 0.2. So I could label each of these. Again, if I want, if you find that helpful, go for it. Okay, so what do I have to do here? The first one looks like it's in between 0.4 and 0.6. So that would be 0.5. And then I have 0.2, 0.4. So I'm just going through and finding each of these pieces of data. Okay, this one here, day 4, looks like 1.1. Day 5, 1.6. Day 6, 0.9. Day 7, 0.7. Day 8, 1.3. Day 9, 1.5. Oops, I'm running out of space. I wrote too big. It's all right. Day 10, 0.8. I'm just going to continue this down here for now. Day 11, 0.5. And day 12, 0.1. Okay. So again, having a calculator is going to make this so much easier. You don't want to have to add all 12 of these pieces of data by hand. So first thing I want to do is just add all these up. Okay, so take a moment, plug in your calculator. Let's see what we get as our total here when we add up all 12 of these pieces of data. Okay, so again, this is just step number 1 for finding the average. We've got to figure out what are all of our data points representing, and we'll add them all up. You should get a total of 9.6. So over those 12 days, they got a total of 9.6 inches. Now, to find the average, I'm going to take 9.6, which is my total, and divide it by the 12 days, or the 12 data points that we have. So once I've added them all together, I get 9.6 as my total, divide that by 12, and this works out nicely to be 0.8, so 8/10. And if we needed to label this with units, this would be inches per day. So the average amount of rain here is 0.8 inches per day. All right, let's do another example. Here's a bar graph. Students were surveyed about their favorite pet, and the bar graph shows the results. If each quantity were to represent 5 students, how many students were surveyed? So pretty interesting question here. Notice this piece of information. If each quantity were to represent 5 students, how many students were surveyed? So what this means is that on this graph, okay, we're shown a quantity. That's my vertical label here. Okay, but each quantity is actually representative of 5 students. So if we're looking at dogs, for example, okay, I've got to be able to analyze my axes here. So in between 12 and 16, this would be 14. I'm just going to label each one here. 14, cats would be 16, fish would be 4, birds would be 8, gerbils, so this would be 4, 5, 6, this looks like this would be about 7. And then pig would be 3. So you've got to be really careful. Don't jump to conclusions. Make sure you're really being as accurate as you can with these numbers. So this is not how many students were actually surveyed. This is just how we're representing it on the graph. So to find the actual total number of students, we're going to multiply each of these by 5. What I might do is just first add these up. So 14 plus 16 plus 4 plus 8 plus 7 plus 3. So when I add those together, I get a total of 52. So that's the quantity that they gave us was 52, but they're telling us that each one of those little data points is actually representative of 5 students. So we're just going to multiply 52 times 5. And that gives me 260 as the total amount of students that were surveyed. Okay, so this is just another type of question that they could ask you and just kind of see if you understand how these graphs work. Looking at this type of graph, again, they could ask you about the favorite type of pet, the least favorite type of pet. Another question they like to ask just basically makes you figure out which sentence or which statement they give you is true. So they might say something like, the amount of students that favorite pets were fish and pigs is equal to the number of students that have a favorite pet of a gerbil, because fish and pig, if you put them together, would be 7 and gerbil is 7 as well. That would be one that is true versus, they'd give you some other information that was not true. You'd have to kind of go through and use process of elimination. So you will see questions like that in your Smart Addition courses and the practice tests. So make sure you check those out because those are just really good practice too for multiple choice test taking strategies using process of elimination. I didn't really add those in here because I wanted this to be a little more open-ended. But you will definitely see questions like that. So you have to be able to kind of like analyze each option and see if it works or not. All right, let's do another. The following circle graph shows what a family spends their income on each month. If the family earns $5,000 a month, how much money are they spending on their mortgage? So they're telling us they earn $5,000. How much are they spending on their mortgage? Well, their mortgage is right here, 20%. So this is saying that they're spending 20% of their income, of their $5,000 on their mortgage. So turn it into a decimal, multiply it by that total amount of money, and you should get that they're spending $1,000 on their mortgage. Okay, so we did a lot with these graphs. I want to dive into a few other statistical topics that we need to know. First one being mean, median, and mode. So mean, median, and mode. You may have heard of these three little musketeers together before, as early as elementary or middle school. But these are three of the most common, what we call measures of central tendency in statistics, which just means measures of the center. How do we find the center of data? And these are a few different ways that we can do that. So in this example, I've given you a set of data, and we're going to go through and find the mean, median, and mode. So let's talk about what each one of those are. So the mean is the sum of all numbers in a data set divided by the number of elements in the set. So that's a mathematical definition. It's basically just the average. So just like we did previously in a question, that just means we're going to add all of our numbers up, that's the sum, and then divide by the number of pieces of data we have. So we'd have to do 1 plus 1 plus 2 plus 3 plus 3 plus 4 plus 4 plus 4 plus 5 plus 6 plus 6, okay? Over, well, how many pieces of data are there? So I would have to count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, and for this, let's just say we're going to round to the nearest tenth for anything that doesn't work out perfectly. So if I'm adding all of these data points up, okay, I get a total of 39. So again, use that calculator, add these together, 39 over 11. So when you divide that, you should get a decimal, but if we round to the nearest tenth, you should get 3.5. So the average or the mean of this data set is 3.5. Okay, so the median, another measure of central tendency, is the middle number of a data set when written in order. So in this example, this one's just nice to start out. I'm going to rewrite it. It's already written in order. And when we say in order, we just mean from least to greatest. 6 and 6. Let me make sure I didn't skip any. Okay. So to find the median, what I like to do, I'm just going to cross out one at the beginning and one at the end until I only have 1 or 2 numbers left. In this case, I have an odd number of data points, so I will only be left with 1 in the middle. This would be my median. My median would be 4. If we had an even number of data points, which we will see later, then you have to find the average of the 2 that are left over. But for this one, we just have a median of 4. Okay, so mean is the average. Median, you can just think of the middle, like when you're driving a car, the median is in the middle of the lanes. And then the mode is the number or numbers that occur the most often. Mode, M-O, most often. There can be no modes if they all occur the same amount of times. There could be one mode if one occurs more often than the others, or there could be many modes. There could be multiple different modes depending on the type of data set. So if I just write this out again so you could see the data, super helpful if they are in order for this as well, because it's a little bit easier to see which ones occur multiple times when they're all next to each other. Notice how 4 happens 3 times, and that's the most of any of these data points. So 4 would be our mode. 4 happens the most often. Okay, so mean, median, and mode. One other piece of data for statistics that can be really helpful is to find the range. So I mentioned this briefly when we were talking about some of our graphs. The range is just the difference between the highest and lowest values in a data set. So maximum minus minimum is essentially what we have to do. So the range of this data set, the max is 6, minus the minimum is 1, so the range would be 5. Okay, pretty straightforward. That one's quite easy. So mean, median, mode, and now we also have range. Okay, so ready to do some examples? All right, find the mean and median for the data set. So to find the mean, what I need to do is find the average. I need to add these all up and divide by how many pieces of data there are. So I would just plug into my calculator 10 plus 20 plus 40 plus 20 plus 30 plus 50 plus 40. Like, it doesn't matter if these are in order. Just take a moment, plug all of these in your calculator. Okay, so add all of these up. So we're going to find the sum and then divide it by the number of pieces of data. I'll give you a moment again to try it on your own. I'm getting 570 as my total, as the sum. Now, how many pieces of data are there? Where there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 14, 15. So 15 pieces of data. So if I take 570 and divide it by 15, just label what I'm doing here. This is the mean. I'm going to get 38. Okay, so the mean is 38. If I look at my answer options, the only one that gives me a mean of 38 is this second option. So I'm pretty confident that that's my answer. Is it possible that I made a mistake? Yes. So should I probably find my median anyway? Yeah. And also, we want to practice it. So thinking about test taking strategies, realistically, if we are really confident we did this correctly, which I am, option number 2 is the only one that makes sense. But let's just double check. So median, I need to have this data in order from least to greatest. So I'm just going to go through and rewrite this data. I like to cross them off as I go. I'm just going to put it in order. And when I cross them off, that just allows me to make sure I don't skip any. And if I have any left at the end, I just go back and add them in, because that definitely happens sometimes, especially when we have like doubles. So 30, now 40. Looks like the next one. Okay, so it just takes a moment. It's not a big deal. You don't want to rush. You don't want to skip anything. Looks like I got them all here. You can totally count them and make sure you have all 15 as well, but I'm pretty confident I did that. So to find the median, the process I like to use again is just to cross one off in the beginning and one off at the end. And the only number left in the middle is 40, so that checks out that my median is 40. Okay, so mean is the average, median is the number in the middle. Just make sure you put it in order from least to greatest first. All right, ready to try another one? Let's find the mode and range for this data set. So we did mean and median, let's now do mode and range. So to find the mode, it can be helpful to write these in order so you can see them next to each other, or make like a little chart or a table. I'm just going to write them in order just so I can see what's up. So I have 10, and then I have 10, and then I have 20, 20, 20, I have 30, 30, 40, 1, 2, 3, 50, 60, and then there's just a 70 and an 80. So if I'm finding the mode, which one happens the most often? There are 3 20s, but there are also 3 40s. So this is an example of where there are multiple modes. There's more than one mode. The most number of occurrences is 3. 20 happens 3 times and 40 happens 3 times. So the mode would be both of those numbers, 20 and 40. Okay, so looking at my options, it has to be just 20 and 40. It has to be option number 3. And just to confirm, the range would be the highest minus the lowest, the max minus the min, which would indeed give me a range of 70. All right, let's look at a little bit different type of question here, a little bit more algebraic based. The mean of 8 numbers is 71. The numbers in the data set are 72, 75, 64, 80, 79, and 68. Okay, so these are numbers in our data set. This tells us that the mean of 8 numbers is 71. What is the other number in the data set if the number is the mode of the set? So a lot going on here. The mean of 8 numbers is 71. What that part of this question tells me is that when I add all of my numbers in the data set up, there should be 8 of them. When I divide that sum by 8, it's going to equal 71. So let's see what we've got here. We've got 72 plus 75 plus 64 plus 80 plus 79 plus 68. So that's 1, 2, 3, 4, 5, 6 pieces of data, but there should be 8 numbers. So the other number of the data set is the mode of the set. So remember what mode means? Mode means it happens the most often. So far, every number only happens once. It seems like the missing number is going to happen twice. So I'm just going to call that number X. Okay, whatever we're trying to figure out is X. So we'll have 2 of those in order for that to be the mode. So now when I add all of these up, divide by 8 because there'll be 8 pieces of data. Okay, this has to equal 71. My mean is 71. Now, let's try to solve this equation. First thing I might want to do is just use my calculator, add all these up. It's going to make it look a whole lot simpler. So I would get, okay, I'll give you a moment, give you a moment to try, because practicing with your calculator is certainly important. Try to add all those up. Let's see what we get. So 72 plus 75 plus 64 plus 80 plus 79 plus 68 is giving me 438 plus our 2x, all divided by 8 is going to equal 71. Now my goal is to get x by itself. So what I might do is multiply by 8 on both sides. So 438 plus 2x is what I have left on the left side. 71 times 8 gives me 568. So now I'm just using my algebra skills to get x by itself, subtracting 438 from both sides to get it to cancel out. I get 2x equals 130. When I divide by 2, I get x equals 65. So what this tells me is the missing number is 65. And I also know that it's going to happen twice since it's the mode. So what is the missing number in the data set? It has to be 65. Okay, so they really do like to ask questions like this where you have to find a missing piece of data if you're given the average. So definitely use this question as a guide for, types of questions that can be just a little bit further, a little more advanced, a little bit more of a deeper understanding is needed to answer these questions. So they really like questions like this. All right, we've got a few more here. Let's try this one. The table shows the weight of 100 laptops. Find the mean weight to the nearest hundredth of a pound. So I've got 100 laptops here. We need to find the mean weight. So again, mean is just average. So I'm going to add all these up and divide by the number of pieces of data. The interesting thing about this is that it's given to you in a table where you have weight and then quantity. Okay, so I'm not just adding 100 numbers up and then dividing by 100. I mean, I could, but not very efficient. So what we can actually do here is multiply each of these pieces of data. So 3 times 35, okay, would give me 105. So 35 of the laptops weigh 3 pounds. That's a total of 105 pounds. 4 times 24 gives me 96. 5 times 19 gives me 95. 6 times 11 gives me 66. 7 times 11 gives me 77. So you could either do it like this, or if you feel more comfortable, you could write it out like this to simplify as you go, but it's essentially the same thing. I'm just trying to be a little more efficient here with my table. But what you're still going to do once you multiply and add them all together is you're going to have to end up dividing by 100. So from here, I've already multiplied these. So let's just take these and add them together to find the sum. Because again, to find the average or the mean, I need to find the sum and divide by the number of pieces of data. So when I add all these together, I get 439. And I need to divide that by 100. So 439 divided by 100 gives me 4.39. So the question was, what is the mean weight to the nearest hundredth of a pound? Well, 10th, 100th place is already to the nearest hundredth, so this would be my final answer, 4.39 pounds. Cool. All right, just a couple more questions for us today before we wrap up. Here is a line graph. This says, what is the average amount of rainfall, the average amount of rainfall per day for the 12 days of data shown. So we did a question similar to this before. I want you to go ahead and try to get a little bit of a start here on this question. So I've got my rainfall amount in inches as my vertical axes, my vertical label, the day here. To find the average amount of rainfall, we need to figure out the value of each of these data points, add them all up, and divide by 12. So I'm going to give you like a 30-second head start, and then I'm going to start writing out the data here. Let's see. Okay, so I'll just let you work. I'm just going to write out the data points as I see them. Okay, and then you can check before you go adding them all together. Okay, so a lot of this is also just trying to keep yourself organized, writing things out so they're easy to read, and so you can come back to this when you have to plug it in your calculator. Okay, so once you have written out all of your different data points, you found all the values, you're going to add them all together. Okay, so you can check yourself with me, make sure you agree with each of these data points, and when you add them together, you should get 9.6. Now, if I take that sum or that total divided by the 12 number of days, oh, this looks familiar. It's a different graph. But somehow we've got the same answer, which is kind of funny. We get 0.8. And remember, just like before, this is inches and days. So the average here, or the mean here, is really just 0.8 inches per day. That is the average amount of rainfall. Cool. So let's finish this up. Before we do our last TEAS practice question, check out the TEAS 7 online course and mobile app at smartadditionacademy.com. The course has everything you need to review for math, English, reading, anatomy, biology, chemistry, and scientific reasoning, in addition to 8 practice tests, flashcards, and interactive lessons. Now let's finish out this math practice session. Thanks for watching. A set of 8 numbers has 50 as the smallest number, and the median is 55. Which of the following sets could be the numbers? So if I need the smallest number to be 50, that would be the first thing that I would check on. And if you notice here, all of these, it looks like they're already written in order, which is very nice of them. All of these have a smallest number of 50. So these all still work. Now we have to figure out which one has a median of 55. So again, I already noticed that all of these were in order from least to greatest. So now I can just try to find the median. So let's just work our way down. I'm just crossing off one at the beginning and one at the end. Notice how, again, we have 8 numbers. This is an even number. So we're going to have to find the average of the 2 that are left. Or basically, what's right in between 53 and 55? This would be 54. So my median would be 54. This one doesn't work. Let's try the next one. Cross these out as we go. I'm looking for a number in between 54 and 56, which does happen to be 55. If it's not that straightforward in the future, the process you could use is also just add them together and divide by 2 to find the average. Okay, so this would be 110 divided by 2 is 55, so this checks out. I'm just going to confirm my answer here, make sure there's no room for error. What would be the median here? 55 and 56. Right in between that would be 55 and a half. And then lastly, let's see what we get here. This would be in between 54 and 55, 54 and a half. So the only one that works out is option number 2. Oh, all right. So we talked about the 3 main types of graphs that you need to know to how to interpret. And also, you need to be comfortable creating these graphs a bit. So hopefully you feel fairly comfortable with that. We talked about mean, median, and mode, as well as the range, and then did a bunch of examples of how using the graphs and other visuals comes into play when we are having to find that mean, median, mode. They can kind of, these graphs can ask similar questions versus if you're just given a piece of data. So we are all set for today. I hope you found this helpful. If you have any other videos you'd love for us to make, leave that there for us to go on going forward. And I wish you the best of luck in your studying and on your entrance exam.